So I'm going to talk about some really nice features that I discovered in the weekly challenges. And actually, well, everyone can discover those features. But yeah, sometimes you feel that you don't know Raku. Sometimes you feel you really know it really good. But still, it's sometimes you can see solutions which are completely unexpected. So yeah, I have to finish in 10 minutes. So yeah, we're good. So probably we can we have enough time to go through at least one of the tasks. So my preference here in this talk is just to find some solutions that are suitable for working with sequences. So numerical sequences are really good for Raku, and yeah, you will see actually why. So okay, so week number 1 to 3, 123, task number 1, ugly numbers. You are given an integer n bigger than 1 or 1. Write a script to find the nth element of ugly numbers. And ugly numbers, there's a definition. Those numbers whose prime factors are 2, 3, or 5. For example, the first 10 ugly numbers are these. Actually, I don't know why they're called ugly, because the list is quite like regular, but nevertheless. So, and the example for the input number 7, the 7th ugly number is 8. So, okay, so let's look at the solutions. I selected a few solutions for this task, actually 4 solutions. And you see the name of the person and you see the link. And here is the copy, but this is a slightly modified original code because I just didn't want to run parameters through command line. I just wanted to run the program and see the result immediately. So yeah, this is not the original one. This is a bit slightly modified, but all the ideas are definitely kept. So okay, so the solution by Jan Kernavik, and he has this approach. So first of all, he creates 3 arrays. And these arrays are actually defined using the sequences. So this 3 dots is the sequence operator in Raku. And you pass kind of pattern 1 to 4. And this is definitely like a geometric progression. So the next number is 8, and it goes up until it meets this number. And actually, like definitely 50 here is not the element of this sequence, but Raku will still stop as soon as we reach this number or we go beyond. Then we have the factors for 3 and factors for 5. So that's good. But after that, the magic, the really Raku magic happens, and we see this selected line. So we can just run the program and see what's there inside. So first of all, yeah, well, okay, maybe we can do it like this. So it's Raku 1, 2, 3, 1, Raku. Right, so here's the sequence. Well, definitely more or less the same for the other 2 arrays. But when you do this, you will get this long list of products. And these products are actually well, yeah. So first of all, you take these 2 arrays and you make, what is it, cross product. For each pair of the elements, you can basically, this is the cross operator, which is cross meta operator, which takes the regular operator star, which is just multiplications. And basically you multiply all the numbers from here by all the numbers from here, and you've got the result. And after that, you repeat the procedure with the 3rd array, and you got this list. The list is unsorted. So that's why in the original code, so let's go back to the original code. In the original code, well, so actually here is the original thing. I just added say to see the result. So we've got this, which is this big list. And after that, Jan sorts this, these numbers. But he's doing it in his manner. So in other solutions, actually, we'll see it later today. You will see that he really likes this pattern. He often uses this and then, what is it, binary operator, because it takes 2 arguments before and after, well, on the left and on the right sides. And it just, how it works. So actually, it's a kind of combination of if defined and then apply a method. So it means that if this is defined, then to this we apply that. So basically to this long array, we apply the sort method. So we sort the array. And after that, again, the same procedure, we apply this. This is a really interesting feature of Raku. So yeah, definitely, for example, if you have an array, you can just subscript it with a number, but you can also call a method which will give you exactly the same. So, and actually this is what happens here. So we apply a method to the result of all the previous manipulations, right? So basically effectively it means that you can just do it like that, right? So yeah, but in Jan's case, he always wants to use this and then. Right, so let's run this again, and now we see the results. So the result is as expected, as explained here, it's 8. So this is the correct result. Okay, so that's good. Let's go through another solution, and probably after that I will finish to continue with another talk by a different speaker. And then reloads $_ for following commands. Yeah, okay. Yeah, so yeah, basically, yeah, that's correct. That's correct. That's a good notice from Bill, good note from Bill that I got in chat. And basically after and then you've got the $_ variable set. So basically this is what you've got in reality, but you don't have to mention $_ and you can just use dot just on kind of nothing. So this is the actual code, right, that Raku understands. Okay, so another solution by Lucas Ransan. So here's another interesting thing. As Mohammed, for example, mentioned just a few minutes ago, that he really enjoys multi. In fact, actually, this is multi-sub, right? But you don't have to use sub keyword. You can just use multi. And with multi, you can create a variant of the function, which just accepts like a constant. Like in this case, it only triggers when you pass 1 to this function, and it always returns true. But the second variant needs an integer, which is unsigned, this u, and this big smiley is actually it means defined. So it's not just that you can create a variable and leave it empty and pass it to the function. No, it will not like it because it wants something defined. And it returns the Boolean. So notice that here is the class name, here is the value, right? And this function returns the recursively called function with a different value, of course. And here, you see, so there's another interesting feature of Raku. There's the divisibility operator, %%, which is roughly, well, probably not roughly, which is actually equivalent to this one, right? So if you want to get the modular operator like that, and after that, if you will negate it, you can write the same as this. But basically, it means that the result is true if A is divisible by B and there's no remainder after that division. You try that for 3 different numbers for those factors. And yeah, and otherwise basically return false. So yeah, I see probably it's not the best thing. Well, I kind of don't like, I would prefer still return here, but yeah, well, why not? But here is another interesting, actually a collection of interesting things. So first of all, we see the range. 2 dots means range. Range of integers started from 1, so 1, 2, 3, and up to infinity. And this infinity actually is the Unicode code, which you can replace with either star or with inf, but definitely this one is really cute. After that, you're trying to grab these numbers using that function. And what happens here? So you see, so actually, well, okay, there's the code block, which grep will execute for all the numbers from this range. But we see that it's like something strange here. And this actually is the method operator. I think we saw this pattern a couple of times yesterday and on the day before in other talks. But this actually means that we're trying to call, again, on $_ we're trying to call a method called ugly, but these 2 characters make us actually, well, allow us to call the function with that name and the $_ here will be the first argument $n. So it's kind of, we pretend that this is a method, but actually we have a function with the same name. Yeah, why not? And after that, so yeah, you just take the index. Okay, Raku 1, 2, 3, 2. All right. Yes. Okay, yeah, so it works. Yeah, and Daniel said that he doesn't like return, if I'm correct. But yeah, so yeah, of course, I would say return, but actually probably some people would prefer even the more explicit construction if something then else, and even there's return in every branch. Then so some people would prefer, some people probably from with classical education who follow those classical rules, probably this will be the best idea. But definitely, yeah, this is my preference, and probably this is also really good. Right. So okay. So I think we can continue with my presentation. And last time we were talking about the solution of the ugly numbers, week number 123, task number 1, ugly numbers. Just a quick reminder that these are the numbers whose prime factors are 2, 3, and 5. We looked at 2 of the solutions, and in the last solution, there was the thing when we grep using this method operator, which is using the function, and you kind of call it as a method. So let's look at the next solution, and immediately we can see the same construction with grep, but this time it's just a regular function, and you just see the difference in syntax. So you have to pass some variable. In this case, it's just $_. Yeah, basically, I don't know who prefers which one. This one is definitely, well, it's using $_, which is kind of, well, let's not call it line noise, but still. But this one is using the line noise on the other side, right? So yeah, but okay, so in this solution, so we have another version of this sequence. It's not a range anymore, so it's a sequence of integer numbers, so you can generate 1, 2, 3, 4, 5, and so on until infinity. And we only need those numbers which are greppable by this predicate, which is just a function. Yeah, so nothing special here. But again, so in Raku, you can restrict your arguments, even if you only have a single variant of the function, like in this case, there's only one sub, there's nothing like multi-sub or something. You can still limit your arguments with the type restriction. You can append the where clause, and yeah, and just to make the possibility to change the value inside the function, you can add the isCopy trait. And where are we modifying the value? Actually, it's here. So we make the division. Basically, it's kind of this, but with integer division, while this number is divisible by either 2 or 3 or 5. Yeah, so simple. And we return the Boolean number. So yeah, I think some people, and I even know who, can prefer this one. Well, actually, yeah, in this one, this is fine. Yeah, I just don't, I would try to avoid situations when you return something like that. Okay, so that's the code, and maybe we can run it. 1, 2, 3, 3 Raku. So yeah, it gives the correct result. Okay, going next, and the final solution for this task is the solution by Markus Holzer. He's really, he always submits really interesting solutions, and here's one of them. Yeah, again, so some may be surprised by the number of special characters here. And actually, this is where the program starts. And right, but I think, yeah, we can still understand what's going on here. So here we have the range, again, all the numbers starting from 2, and it's a range. And we have a separate number, 1, comma, and basically, yeah, so what we are doing here we're passing 2 elements, 1 and this, but this is actually, if it will generate us more than 1 value, then we will just flatten this using this vertical bar, and we just get the list of those numbers. And okay, so we are grepping, and the condition here is this. So this star is one of these numbers from this range, and we are grouping the numbers using this factors function, which returns something, and we demand that all of those returned values, all, belong to this list, right? So we're using the Unicode character here, right? So simple. So, and after that, so you can just subscript this. So is there anything interesting for us inside the function? Well, maybe the only thing, because we kind of saw all the rest, but this one is specific to Marcus solutions. So he puts this close embrace like at the end of the last line, just, well, yeah, probably it's also fine. But then kind of it's close to Python where you don't need it this at all. Okay, maybe we can just run it, run it, Raku 4. Right. Okay, that's it with this task, and we can continue with, so I will just go until I have time, and I have, I have material. I'm going deeper to the history of this weekly challenge, and it's week number 122. The task, the first task, is called the average of stream. I really like this task. They're given a stream of numbers, at n. So here are the numbers. Basically, I just reading it from somewhere. Write a script to print the average of the stream at every point. So that's actually, this is the task for creating an optimal solution, an optimal algorithm. But of course, in our case, it's not necessarily true. So let's look at the solutions that were submitted. And again, I just give a small reminder that this is not a direct solution. This is not a copy-paste. This is a copy-paste with some modification. So I just added these numbers to avoid typing from the keyboard. Okay, so this is where the program starts, and put. So yeah, the difference between, did we see put earlier? Not today, right? So the difference between put and say is that one of those functions is using .str method to, which is applied to the argument to get the string, and the second one is using .gist. So they produce sometimes a bit different results, well, if not always. For our cases when we have arrays lists. So we are doing this. So this is a construction probably, which is a bit strange construction. So what this does, probably we can just look at this. Raku 1 to 2, 1. So yeah, so it just gives us the indices of these elements, which is, yeah, well, probably we can just replace that. If we want to iterate over indices, we can just do this, right? It will give us exactly the same, but again, never mind. So then we map those indices to something, and inside the map we've got this $_, which takes the values 0, 1, 2, 3, and so on until the last element of this input stream, and you can just call the average. And the average is actually, yeah, this is what Daniel suggested on the first day of the conference. So you just take the sum and you divide it by the number of elements. Of course, yeah, instead of colon.lms, you can always do it like that. Yeah, and of course, instead of sum, you can do it like this. But okay, so right. So let's run this. Right, so this is the result that you have to remember, so that it's the correct result. We expect this to see in the other solutions too. Right, another solution Jan Kernavik gave us here. So give it this solution. Yeah, you can immediately recognize it by this use of and then, what is it, operator, right? So here, it's an interesting solution as well. This is why I chose this one for this demonstration. So we've got this and then, and you've got two things, two operands on the left side and on the right side, right? So on the left side, we've got this triangular sum, and probably it's worth showing the result. So this is like what we can do. Raku 1 to 2, 2. So this is the sum. So first we've got the sum of the first element, then we've got the sum of two elements, then the sum of three elements, and so on. So these are the numbers 10, 30, 60 are just these sums. And now we are using these numbers on the left side, and on the right side, we have, what do we have here? Yeah, so on the left side, this is $_, right? This is our list. And on the right side, we've got this range. Basically, we just give numbers to these elements, and we just divide them one by the by corresponding elements. Yeah, I will get back to this plus from the comments in chat. So, and the zip element just basically just zips those. So we divide 10 by 1, we divide 20 by, well, not 20, sorry, we are working with these numbers, with these numbers. We divide 30 by 2, we divide 60 by 3, we divide 100 by 25, and so on. And after that, well, 3. So we get the result. Yeah, it's longer than we have previously seen, but nevertheless, these numbers are correct. So, right, so regarding this plus here, and probably we've got this star here. So the thing is that, well, maybe we can try to reproduce Raku. So for example, we have a function that takes an array, and just let's print this array, right? Or maybe even dump it just to see. And then I call this. What happens here? Maybe some numbers which are bigger than 1. So what happens here, Raku T? So you cannot do this in Raku because it expects a single argument. So you can, yeah, I don't know. So what you're going to do, you can try to imitate it with something like that. So that's the single argument, but instead you can just use this and you're done, right? So you pass in the array. There's a modification, a plus, we're passing this. So what's the difference? I forgot. Honestly, I forgot. So yeah, you can probably search for this in the documentation. These slurpy functions are really like, you can also try to do it like this, but this is actually for the opposite situation when you pass in. So yeah, for the opposite situation for this. But probably, well, yeah, I don't know if it's probably, it's, yeah, it's an easy, the low hanging fruit if you know, if you do know regular expressions, but I would not be that confident. Just find it in the documentation. I'm 100% sure it's there. Docs, Raku, I don't know, but yeah, actually that's the good case. So what? What? Yeah. So it's yeah, it's correct, but probably this one, right? So Slurpy parameters, and if you go so Slurpy, but where is plus? So see, so plus single less variables. Oh my god. Well, yeah, the thing is, I knew the difference, but really I forgot the difference. Okay, so please excuse me for that. And again, so I don't know how to find it. Signature, signa. Okay, so the specialist. Right, so signature of right, so that's the Slurpy thing that we saw earlier, and right, so let's see here. Single Slurpy parameter created using plus engages the single argument rule, which decides how to handle the Slurpy arguments based upon context. Basically, if only a single argument is passed and that argument is iterable, that argument is used to fill the Slurpy parameter array. In any other case, plus works like so okay, so it's I wouldn't say that it made us like closer to the answer, because we see now the another one, star. So yeah, I think it goes beyond the my current knowledge. Well, again, I tried to understand it a number of times. As Larry Wall said, it's so easy, so that I learned it 5 times. Okay, so right, so probably you can also try to pass like empty elements and see what goes in the result and what's the difference. But again, probably it's better just to sit and learn. But nevertheless, so let me go to the next example, And this next example is the code submitted by Bruce Gray. And it's more or less the same. So again, it's just using the zip meta operator with the division operator inside it. So we divide this by this by, well, each element, well, element by element. But just for clarity, Bruce introduced two arrays. One of them is constant. It's again just the range from 1 to 3, 4, 5. Basically, these are the indices of those elements, and these are again the triangular sums. But the more interesting thing, well, comparing to the previous case, happens here. So here we have the sequence 10, 20, and up to infinity, and we're using the Unicode Operator 3 dots, so we could use just 3 ASCII dots instead. Raku 1, 2, 3. Right, so the sequence is here, and we're just taking the first 25 elements of that. Right, okay, so Lucas Ransan gave us this solution. Well, actually, this solution, it's an interesting solution. We still see the same parts as before in the previous two solutions. We have this triangles sum, and we have this infinite range, basically all the natural numbers. Right, probably Raku should, well, not Raku should have introduced some sequences like these. So why bothering us of trying to create either this or 2 dots or 3 dots, because it's all the same, right? But nevertheless, but this is the hyper operator, and it's again, so if you have two operands around this construction, by the way, again, so this is Unicode, which can be replaced with pure ASCII. So again, we just divide it element by element, and as soon as this array is definitely shorter than this one, the hyperoperation will just stop after we reach the last element on the right, so the shortest array wins. The only thing is that you can, well, basically these hyperoperation operators are quite powerful, but sometimes you have to think which direction. So there are like how many, like 4, right? 4 different directions that you can use, and you have to really think. And basically, the shorter, well, the sharper corner to which, so you have to think to which side this sharp angle points. And in some cases, Raku will produce error if it will find that the elements do not match by number. But in this case, this is the shorter array, and this is fine. This array can be as long as it can be, and it will not be used entirely, right? And after that, yeah, Mohammed, this is really the kind of things I like to do when I go through the solutions. But yeah, making video every week is a pain. Okay, so and yeah, I think I added this just for clarity to explain the difference between, right. So, and yeah, and after that you just print. Let's run this solution, Raku 1, 2, 4. Voila, so we've got the result printed differently, but well, who cares? Actually, all the Perl and Raku weekly challenges, the tasks, they do not require the proper output, so you can output more or less in whatever format you want. But what I wanted to add to this solution, this is a pattern here, right? So the pattern for printing simple, just to iterate and print, is this in Raku. So if you run this again, so 1 to 3, but basically this means that, right? So it's calling the method say on the $_ variable, and it's topicalized every time in the loop. The mistake there, which you can make probably is just to leave it as is, because this is how you can iterate in Perl, right? But it doesn't work. So it's just say, and it either needs to be a method call, or it requires some arguments, something like that will work, right? So yeah, but the pattern, I believe the best pattern in Raku is this. Okay, I think this is it for this task, and we can move on to another one. I chose this one, so it's quite distant from the previous, but it's simple enough to just explain, and it's powerful enough to display some more interesting Raku features. So the task is called sum of squares, and you're given a number n, which is 10 or bigger. Write a script to find out if the given number is such that sum of squares of all digits is a perfect square. Well, perfect square, probably just a square of integers, of an integer, right? Print 1 or 0, basically true or false. And there are some examples, and I will use these two, 50 and 52. And just remember that in the first case, it should be, well, true or 1. In the second case, it's false. All right, okay, so let's go to the code, and this is the first solution I chose, Feng Chang, and again, this is the real code from the solution, and this loop, you will see it in other solutions as well, is just my addition to run this twice for those numbers. So that's, again, a very common pattern that you can use efficiently in Raku. If you need to split the string to characters, just use this method, comb. Well, just letters, comb. This comb just is the same as split by empty, but it's much better because, first of all, it's shorter. You don't have to pass any arguments. And I believe that, well, we can try like ABC split empty. So yeah, I see. So let's do it like my A is ABC split empty string DDA, right? Right, so we see, so there are additional elements here. Yeah, the Raku is also, yeah, good, but probably DD is also fine. Yeah. By the way, does this work? No. This works. Right, so so this split with empty argument, well, with an empty string, will add us some empty elements which we probably don't want. But comb ABC comb Raku will just give us the sequence with exactly 3 elements. Well, probably you can say this is what is it? This is an array. We can see it here, and this is a sequence. But well, in our application, this is well, all fine, because, well, who cares? We just got the list of numbers, and we can work with them. Okay, so then there's this fine again Unicode operator, which will just apply all the rest to all the elements here. The only thing you have to like take into account is there's no guarantee that they will be executed in order, in the same order as the elements in this array or in the sequence in this case. But yeah, so probably you will, well, yeah, just think that that can happen. After that, so because this was a number, so $n is a number. When you apply this, you basically work with this number as a string. So Raku should convert it to a string, then split to different characters, and those characters are characters even if they contain digits. And that's why we call, well, not we, but just Feng Chang calls int method. Probably it's redundant. Probably it will work without that, because after that you're trying to map these characters like 5, 0, 5, and 2. And you are trying to, well, basically make squares out of those, right? So this is the, well, actually what this is this is basically is like this, right? So it's a code block. It's a code block which just, the shortest possible version is just use this Unicode power, well, superscript. You can add the skip empty argument to split to get the same behavior as comb. Yeah, that's correct. That's correct. So, and actually, this is not only correct about this particular split, but probably you can, like, for example, the dot first method, it has dot first. It has, for example, and well, something, the named parameter, which will change the direction of search. And probably even if you kind of understand how the method works, and if you never worked with that, just look at the documentation for maybe you will find something interesting about additional keys which you even couldn't imagine that they exist. In case of split, indeed, there's this keep dash empty argument, but yeah, it's not definitely not for golf solutions. And actually, why we should skip? So why should we should generate it first, and so that we should skip them. Okay, so we've got these squares, and after that, we're trying to reduce this, and this is well, it's quite a massive construction. I believe this is also redundant. Yeah, the dot first basically becomes the last, right? With and. Right, so we are trying to reduce it, and we're using this. So what is this? Infix colon plus. Basically, this I believe just the built-in plus operator, which just adds some numbers. The first from the end. Yeah, well, the first from the end, that's correct. But if you're trying, if you're trying to find it for the first time, how would you find it? It's like there's like in JavaScript index and R index or whatever. So like probably it's a bit difficult to find it first. Okay, so you basically sum all those squares here using just the built-in plus operator, which works with numbers. And after that, we already had seen this construction somewhere just here, right? This method operator. So we're trying to call. I forgot where we were. This method operator. We're here. And instead of having a separate function, which we will use as a method, we have the code load directly here. Right. Yeah, just look at the chat. Daniel suggests how you can simplify this construction with infix. So it's, what is it? It's like this, right? That's, yeah, it's better. I don't know if it's better for those people who are not familiar with Raku, but probably this is neither. Okay, but so here we're trying to call a method on everything on the left, and this method is actually a function which we just define here in place. And of course, this function takes some arguments, and these arguments is just $_ which we use twice here. And what we do with this, with that argument, basically here, we just try to understand if the number is the, well, from the definition of the task, if the number is a perfect square. So basically, if we take square root and then put it to the power of 2 by removing the fractional part, we should get the same number again. And this plus is probably we can even use it like this, or maybe even we don't need it at all, because it's still like equals a Boolean result. So why we need to convert it? Yeah, because we need to put it as 1 or 0. That's the downside of many tasks on the weekly challenges, because if they ask to print 1, you have to do something to print 1 instead of true or false. Okay, and yeah, so, and after that, so we run this program, this line of this program twice for two numbers, 50 and 52, and I believe we can get the result. Right, so 1 and 0 is expected. Okay, so correct, but yeah, this is probably the cutest thing in Raku that you can use, and of course, don't forget about this kill. Probably if you want to program the first. Yeah, well, first and but split is probably still useful if you don't want to split on characters. Probably if you want to split on some like substring, split with your friend. Okay. Right, next solution, Jan Kernavik again. So again, you can see that this is Jan Kernavik, and then. I don't need actually why we need these here. But okay, so let's start at the beginning. So the program is, well, the loop starts here, and the program is basically calling this sum of squares function. And again, once again, I always will tell you that, well, you and everyone, that Raku allows dashes in the, in identifiers, which is really cool. Unfortunately, you cannot put 2 of them, but still. Okay, so we are doing some actions, and after that, so we see, so again, this plus so, that's the pattern. You can do it like this, And if it's already Boolean, probably you even don't need it, but nevertheless, so plus so is a quite common pattern in the weekly challenge solutions. It's again just to convert it to Boolean first and then to convert it to a number to get 1 or 0. How did I miss? And then, yeah, well, and then it's everywhere there. And actually, I think that I learned about this thing from those solutions. So it's really helpful. But okay, so yeah, there's the whole family of them, I believe, right? So there's and then a not, and then so yeah, just again, these corners of Raku are probably underestimated, so they're a really cool feature. But in essence, what this and then is doing is just checks if this is defined, then it sets $_, and then it basically passes control to the second operand. So in this case, we split the number into characters. So again, so this was the number. Now we have characters. We work with these numbers with string, and after that, we're mapping those characters, and we work with them as with numbers. So Raku takes care about converting those. Yeah, and this long error, I think I saw those in Raku solutions, in challenge solutions as well. So you can just pass all the data to the next room. So yeah, so but in this case, probably it's exactly the same as this. Well, maybe with the exception that you need some parentheses here. And then, so yeah, but let's keep it as is. And then you check if, yeah, basically, I don't know why Jan chose to use ASCII graphics here instead of doing it like this, but yeah, well, nevertheless. So Raku 1162, voila, so it's the correct result. Well, yeah, definitely it would be correct. Okay, yeah, so in this task, there are many interesting questions, well, solutions. They're all short. They're really handy to just take a look. Okay, so here we have another solution by Luca Ferrari, and yeah, I see. So we have split here, and remember that this split gives us two extra elements which we don't need. They are always empty strings and before and after the list, and we map those to squares to get squares, and after that we sum them. And so yeah, I wonder, so actually what happens. So for example, I have, again, well, yeah, 50 is not a good thing because there's 0 here. So 52, I will split. Well, actually, yeah, in the original task, it's not like this, right? Because it's just like this. We're splitting the number. By this, okay, so we got this split and map. Okay, let's do explicit multiplication. Right, so we see, so we've got this, but after, so those empty strings will be become zeros. Yeah, so you're typing so much that I cannot read everything. I don't know if it's about copy and paste points. Right, so okay, so yeah, by the way, Unicode characters, again, I forgot because I learned there's some combinations that you can press in, yeah, so I did it. So I pressed, what did I press? Control Command Space, and like, for example, I can insert infinity. So on Mac, at least you can just easily type. Definitely, so the second option is just to go on Wikipedia, well, to Google and copy characters from there, or just somehow. But no idea for Vim, but for Mac, yeah, just Command, Control, Space, and actually the good thing is that it remembers the last selected characters and just displays it here. So yeah, what's that, by the way, in Raku? It's still infinity, which is good. All right, so okay. Let's look at the solution, Luca Ferrari. So yeah, in the original, I think it was like this, but I chose to, well, to continue. So we print 1 and well, and continue if the sum is, no, I think I already modified something. So in the original, it was security like this. But why doing it twice? Because yeah, it was like this. We can just move it here and remove it from here. That's, I think, a bit optimized solution. But the thing is that, yeah, so this mapping just ignores those empty strings and converts them to zeros, and those zeros, yeah, just are not taking part in the sum. But all the rest is like this. Raku 1163 Raku. Yeah, I really did it from Google, from Wikipedia. I don't know how to type with the second power or the third power. So, right. Okay, so yeah, this works. Go next. The next is solution by Mark Anderson. And here is the one-line solution. Yeah, well, there's comb here, nothing new. Map, well, with map, probably, yeah, probably, I think all the stars of Raku, right? There was an advent calendar. Oh, where is it? Here it is. So there was, in the end, there was like this. So yeah, in Raku, you can use constructions like this, 3 stars with spaces, or 4 stars and well, 2 stars together. So probably it's, yeah, it's not that easy to understand what's going on here, but actually, yeah, so this is a simple block, not more difficult than this one. It's just whatever code block with 2 placeholders, 1 placeholder, second placeholder, and with plus between them. So it just adds up 2 numbers, and here is the same, but just the operator is star multiplication, and here's the operator is power, right? So very simple. Very simple after you tried to do it a few times. Right, so here we just basically, this is probably the same as, okay, so I can now use it like, so this is the same as this. So so we take the square of those numbers, we just add them up and check if it's the integer, but this check is done differently here. So first we narrow down the result to basically what we can just kind of round, right, it here. So we remove the fractional parts, right? And after that, we match this with the type name. And if it's an unsigned integer, then we are good. We can print 1. Probably U is extra here because, well, in this task, there's no chance that we get the negative number. Unsigned integer, what is, if we have 0 here? Okay, so maybe it's the correct thing. But yeah, that's the pattern to check the type of the value just directly using those type names. Okay, one more solution called Crane. Another interesting solution. Well, first of all, it's interesting because, yeah, you can, well, it's demonstrating that you can align it vertically. Yeah, so you don't necessarily need to use this, or you don't necessarily use this unspace backslash. Oh my God. All right. But so, yeah, but the solution is straightforward. We've seen it a few times, but what we can also see here, well, probably this is a bit redundant because, yeah, because instead of all that, you can just put plus and take everything to parentheses, right? And you don't need this. But the good thing here is just basically this is how to do the same thing differently in yeah, just look at documentation for narrow. It's really a thing. Probably you can. I actually have never used it. I don't know. So probably I just only use around like floor sailing, or .int actually. Yeah, .int is also fine. But narrow probably it's more specific usages. So yeah, in this program you can see 2 different approaches to writing your code in Raku. So the first approach is just to chain all the methods. Yeah, of course, one line or separate lines, it's your choice. But the second approach is to chain function calls. So basically here we call functions, and we can do exactly the same by just doing like sqrt floor, right? So it's the same, so it's your choice. And by the way, yeah, here we're using floor instead of all those narrows and ints. Okay, so let's run this solution. Just to see that it works, but definitely it works. 1, 0. And okay, and the final solution in this series, in this task, is the solution by Yaldar VS. So 2 numbers, we pass through the same story here, but the most interesting thing is, okay, so first of all, here is the interesting thing. So we've got these digits. Actually, it's not digits, it's squares of digits, right? Because we are taking the second power here. Right. Well, actually, a chat is saved, and I don't know how to publish this. I would just copy paste to below the video. Probably it's the best option. I don't know if there's some like personal information there. Probably not. But yeah, chat is somehow important, and I don't know how to synchronize it with video. But well, I do know how, but it requires some work. But they are saved at least, yeah, on my computer. Right here. So we've got these digits, or squares of those digits, and we're using the reduction operator with plus to add those up. So this is really powerful construction that I really enjoy. And actually, do you know that you can use for example, list, what is it? So you can just call your own function here, and basically, so what does this mean for an array? For example, if the array, well, it contains different elements, so basically it means that it's zeros. Well, basically it just lists all the elements one after another, 2, 3, and then Raku inserts this operator just in between those, right? So it puts everything here. And if you're using function here, your own function, you can just do the same here. So Raku will just call these functions in this chain, and it's exactly the same. So it's a really useful pattern. Probably, you have to get used to using this. But as soon as you get used to it, you will just use it everywhere. Right. Right. So, and another pattern here, which I really like to show you. I didn't think about this earlier, but actually that's a good thing to check if the number is around integer, right? If it's an integer, if there's no fractional part. So for example, if you have 5 and if it's divisible by 1, well, yeah, probably I will prefer spaces. It is true, but if it's like 5 and 2 and it's divisible by 1, it is not. So it's false. So basically it's the same as all those constructions when you try to either match it against the type name or compare it with the rounded or narrowed value. It's as simple as this, just %1. I wonder if it's doing the same. Well, in theory, it should be. Yeah, well, it's true or false, but it is probably, it still requires some negation somewhere here or maybe here. But okay, yeah, it's a different story. But yeah, so just keep in mind that you can use this in Raku. This divisibility operator has even more power than I thought before. So Raku 116-6, Raku, it works. Is there a right association version of this instruction? Well, good question, not to me, sorry. But wait, what do I mean right? But if you put the function which is right associative here, it will be, I don't know, yeah. I will not give my fantasies here, but probably, yeah. And widening it. Okay, this is it with this task, and I believe I skipped somehow to the task. No, yeah, right. Okay, so, and the final thing that I want to work with today, definitely there is much more interesting stuff in other weeks as well, and not necessarily in simple tasks with sequences and splitting numbers. But sometimes, personally, I don't like tasks where you have to like go through the matrix or draw something. But these numeric things are really interesting to solve in Raku. So next palindrome number. So you're given a positive number, integer number n. Write a script to find out the next palindrome number higher than the given integer n. So right, so you've got this 1, 2, 3, 4, and the next number, which is bigger than 1, 2, 3, 4, is 1, 3, 3, 1, which is, yeah, you can mirror it, and it's the same number. Right, and here the palindrome, again, the pattern, you will see it a lot in such tasks, in such solutions, is just to compare the number with its flipped version. And again, so we don't care if it's a number or if it's a string, because Raku can handle these. So we can just flip the number and we will get the mirrored version of this number. So in the solution of Aaron Smith, so we've got this number, and what we're doing here, that's a thing. So we start from that number, so we create a range. We start from the number after that number, so this hat actually skips the number itself, and basically we start with the number 1, 2, 3, 5, and we go until infinity, but we do not go there, and we just take the first number, and you see, so this is so yeah, so we already talked about first. There was n, but probably we can look at other useful, where are the keys? Yeah, so you see, so there's the key, but there's no v here, right? This is why I was a bit confused. So there's the key. So we actually saw already keys somewhere with grep, right? With some, well, there was dot keys called on a list. But here, keys, basically, it will give us the index instead of the value of the element. KV will give us both. And P returns those as pairs, right? But what is V? Well, probably it's values, but I'm looking at this, I'm a bit confused. Why is it here? It's without sense and first. Well, yeah. but yeah, well, sense or no sense, but it's accepted, right? So because we can compile this program 114 Raku. Okay. So yeah, so probably we don't need this at all. We can golf this number. So here, so okay, so we've seen this range, and definitely in this case, and it can. But yeah, by the way, so I really want to have some Raku golf contests, because like, look at this. This is something. Of course, you can first how do I do this? Infinity. You can replace it with this. Then I want to gain another character on the first, the first attempt. Yeah, I don't know how to, but the first attempt is using Unicode character, but probably there's no Unicode character for 2 dots, or is there? Never mind. But I definitely know that I can use 3 dots here. The result is the same. It's the sequence, and the difference in this particular case probably is that sequence, you can generate sequence in any order, like this, but you cannot do it for ranges. So it was not sequences, was a range, right? So let's say 4, 10. So, and it works. So it doesn't work with a range with unsorted numbers, but you can do it with a sequence. So in this case, the sequence works, but after that, definitely you can use the. How do you do that? I don't know. Okay, now okay, so I have to copy it from Google. But nevertheless, yeah, definitely you can gain 1 character at least by replacing these 2 dots with 3 dots in 1 Unicode character. Right. So first, and here is basically this pattern. Probably it's wise to take a look at it separately. So basically what it is, it basically is sub, right, that takes basically there's no name, right, for this sub, and it takes num, and inside you've got this num, so that you can use it as this one. Okay, so yeah, but again, the pattern to check if it's a palindrome, whether it's a number or a string, is just this compared with the flip I don't know. Probably we have to have something like this, right? But yeah. Okay, it was the first solution, and there are two more that I selected. So here, Ben Davis, this is his solution. It's a very short solution, and again, so we see, so we see, so this is a variety. So again, we have this hat to start with next number, and we go to infinity, and we select first, and this, so it really resembles this solution, right? So, well, I even can change, see the difference if I will change tabs, but the first difference, the main difference here is how you work with this inline function. So instead of just doing like something like that by introducing some parameters or arguments, you can just use placeholders. And place a placeholder is a construction like this. So, well, the sigil, then hat, and then a letter. And if you have more than one placeholder, like for example x and y, and this function will expect two arguments at its input, and they will be sorted by alphabet. So that's a bit strange thing that you have to sort by alphabet, but in this case you can use it like this, and or even like that. Probably it's cleaner. So, but this is the second argument, this is the first argument. Very, very clean. But if you will use it twice, it will be like the same as you saw in the previous solution, like here. Why not three? Why not equals? That's a good question, but yeah, that's a good question. But actually, well, in this case, probably there's no difference. Raku, but well, yeah, actually, this should be number, right? So, but yeah, well, you don't have to, because after flip you still get a string. Yeah, but then you have to convert this number to a string. So yeah, you still have to convert. I mean, Raku still have to make at least one conversion. So probably they are equally efficient or inefficient. Right. Yeah, but this is a string. We compare it with the number which we have to convert to a string, and now you have number here and you have a string here, and you have to convert this string to a number. So what's more efficient, converting a string into a number or a number into a string? But yeah, for these tasks, definitely it's the same. And again, probably we can use the Unicode character here. Okay, so we can gain one character if we are doing golf. Right, so okay, and finally, a solution by Jan Kernavik. And right, so it's more or less the same, with the difference that so we do not reach the infinity, we stop one item earlier, so probably we can safely remove this, right? But actually, probably in most cases we even can remove this, but probably it will break if we will start with this, right? Raku 1143. Yeah, definitely. All right. But in the case with this head, we just continue and we try to find the next palindrome. Okay, so I think that's it. Actually, yeah, again, as I said, there's much more interesting solutions. Oh, by the way, you see, so here, this author is also using EQ. And after that, we just say first number. By the way, yeah, so what happens, I don't know if it will, right, so probably like head like 10, we can just use 10 numbers. So you see, so it's really interesting, and it's quite easy in Raku just to change the scope of your results. So just take the first of the head, and you see, so with one simple change, which is probably not much longer than the original solution, we can give more solutions. Okay, that was it. I think that's it. And I don't know if you have more questions, but actually, yeah, basically most of the questions can be answered in documentation. And it's really, so yeah, so our homework, or my homework, is to understand the difference between this, and this. Okay, so yeah, I think that's it from my side.